again. This is the second part of my tutorial about PETSc. It will be devoted to very basics of PETSc programming. Here you can see that PETSc provides its own primitive data types like PETSc integer, PETSc scalar, PETSc real. It is actually better to use them instead of building C types because it leads to better portability of your code. It is then very easy to switch between real and complex scalars, and also to switch between 32 and 64 bits. Let me now remind that the communicator is an opaque object that defines process group and synchronization channel in MPI. PETSc defines two standard communicators, PETSc self and PETSc world. PETSc self contains just a single process, and on the contrary, PETSc world contains all processes. So typically for sequential objects, you use PETSc self, whereas the distributed objects live in PETSc world. You can, of course, define your own communicators using MPI routines. So now something about error handling. As I said, PETSc is written in pure C, which means it cannot use C++ exceptions. So instead, all PETSc routines return integer error code similar to MPI. The error code is cached by this check error function or macro. I recommend always to use this macro after each function to get good error report in case of some error. PETSc has quite good possibilities to be controlled by command line. Here we have an example. When you run this program with name program, with these parameters, my int and my real, inside of the program you call PETSc options get int or PETSc options get real. You get exactly these values. Okay, so we can now proceed to the first example. Give me a moment. Here we have our first example of PETSc use. It is a very simple Hello World program. So, this is our first PETSc program, simple Hello World. Notice that we must first call PETSc initialize and at the end PETSc finalize, and how the error checking is implemented. Further, we can use arbitrary MPI routines. Here we use MPI rank to get the rank of the current process. To print the Hello World message, we can use PETSc printf routine. Unlike standard C printf, its first argument is a communicator. I have been already talking about PETSc built-in communicators, PETSc self and PETSc world. The PETSc printf routine prints the message only from the rank 0 process of the communicator. PETSc self includes only the current process, thus each process has rank 0 in it. So effectively, this PETSc printf prints from each process. Okay, so we got the output from each process. And now we will try to use PETSc world. PETsc Conworld is a global communicator that includes all processes. So effectively, this PETsc printf prints from just one process. The output is a little bit chaotic as there is no process synchronization. PETsc provides countable functions to get a nicely synchronized output. To print from processes of the communicator one after another, call PETsc synchronized printf and PETsc synchronized flush like this. You can see we've got a nicely ordered output. Finally, we will test the access to command line options. Let's for instance define a new variable myInt. Now we will call PETsc options getInt like this. To see the effect, we will print the value of the myInt variable. Okay, now compile and run the program. We have run the program without any options, so myInt variable has its default -1 value. Now run it with the option -myInt10. You can see now the myInt variable is now equal to 10. We will finish with discussing PETsc inheritance. PETsc uses only limited inheritance, which consists of 3 levels. Every object in PETsc is an instance of a class like VEC, MAT, PC, KSP, and so on. And all these classes inherit from PETsc object. Functions called on objects, which we sometimes call methods, are prefixed with a class name. A new object is created with a class-specific create function or constructor, matrix create. Every class is further refined to types, specified by this setType function. Here we can see it graphically. You have PETsc object, parent class, then all these classes, and every class can be refined to types. So that's all. Thank you for your attention, and if you have some question eventually. Yes?
PETsc is written in C. How is it possible that it uses classes?
The classes are in fact C structures with pointers to functions which simulate methods. So with it is all. Thank you for your attention once again, and see you in part 3, which is devoted to vectors.